All right, guys, today we're looking at solving one-step equations and verifying those solutions. Okay, so solutions to equations. Solutions are every value that satisfy the equation or make the equation true. Okay, so what that means is the solutions are going to satisfy the equation and make the equation true. So if I get something at the end that is like 2 equals 2, that's true. 2 does equal 2. Okay, so that would be a solution to the equation. Okay, it'll probably make a little more sense when we look a little deeper at some examples here. Okay, inverse operations. The inverse operation of addition is subtraction, right? Think of inverse, think of almost opposite. Addition is subtraction. So what do we think multiplication is? Hopefully, we said division or multiply by the reciprocal. Okay, specifically division. Okay, the square power would be the square root. Okay, so those are inverse operations to operations that we are very familiar with or should be at least somewhat familiar with throughout this first semester here as a freshman. Okay, so balance. We need to perform the same operation to both sides of the equation. Okay, it's important that if we do one thing to one side of the equation, we do the exact same thing to the other side. Okay, we have to maintain balance when we work through these equations. Okay, so let's look at some of these examples. For number one, we have x plus 2 equals 32. Okay, so the way we solve for x here, we're trying to get x alone by itself on this left side, okay? We can subtract 2 from both sides, okay? And notice we do one thing to one side, we're trying to move this 2 over here. We do one thing to one side, we have to do it to the other side. So 32 minus 2 is 30. X equals 30. So that would be a solution to this equation, okay? So for number 2, okay, let's verify it first. Sorry about that. So if we verify the solution, all that means is we're going to put 30 in for x here. So see how it says x equals 30? That's like when we're substituting, we can put 30 in anywhere we see an x. Okay, so we're going to replace this x here with a 30. 30 plus 2, of course, is 32. 32 equals 32. So this is like that first box that we talked about, guys, when it said solutions make the equation true. Okay, this is a true statement. 32 absolutely equals 32. So that would be true. And we know what we solve for is correct. Okay, so we know it's correct. Okay, so what we did here is we solved for x, and then we checked our solution and made sure that we knew that it was verified and actually true. Okay, so looking at number 2, we have negative 3x equals 24. To get rid of this, that negative 3 is written right next to that x, which means we're multiplying here. The inverse operation of multiply is divide, so we're going to divide by negative 3. 24 divided by negative 3, because we do it to both sides, is negative 8. X equals negative 8. Okay, that's our solution. Now we have to verify it. Verify, we're going to substitute that negative 8 into the original equation. Okay, negative 3 times negative 8 equals 24. Now, what is negative 3 times negative 8? Hopefully all of us are saying 24 because a negative times a negative is a positive. And once again, we know we're correct with our solution. Okay, looking at number 3, we have x over 6 is equal to 4. Okay, x over 6 is equal to 4. If we have a problem, that starts as x over 6, okay, this is the same thing as divide. So what's the inverse operation of divide? Well, we know it's multiply. Okay, so we're going to multiply both sides to maintain that balance by 6. Okay, so I would get x is equal to 24. 4 times 6 is 24. Okay, now we have to verify. Plug 24 in for x into our original equation and see if we get 4. 24 divided by 6 is in fact 4, and 4 equals 4. Is that a true statement? Hopefully all of us said yes. Okay, so find our value, our solution for x, verify it by plugging that value into the original and seeing if we get a true statement at the end. Okay, so number 4, we have 2/5 x is equal to 20. 2/5 x is equal to 20. Now a lot of us might look at this and get stuck and wonder what we're going to do with this 2/5. What do we do here? Are we multiplying or dividing? What are we doing? Well, this right here is telling me 2/5 times x. The way that you can get rid of a fraction, the inverse operation of doing this, is by multiplying by the reciprocal. Okay, that was another option there. Multiplying by the reciprocal. If we multiply by the reciprocal, a lot of us might not know what reciprocal means. All the reciprocal is flipping the numerator and the denominator. So we will multiply by 5/2. We flip the numerator and the denominator, and we're multiplying by the reciprocal. Okay? So instead of 2/5 like our original, our reciprocal is 5/2. Our denominator now becomes our numerator, and our numerator becomes our denominator. Okay? Now when we do that, we're left with x is equal to 50. 20 times 5 is 100. 100 divided by 2 is 50. Okay? Now to verify this solution, again, we just plug 50, our solution we found, into our original equation. 2/5 times 50 is equal to 20. And 2/5 times 50 is 20. 20 is equal to 20. That's a true statement. So we know that's true. Okay, next up, we have 55 is equal to x minus 9. Okay, this one's a little different because x has always been on the left side of the equation for us up until this point. Now it's on the right side, okay? So that really doesn't change anything though, because this equal sign means that you can have it on either side, okay? As long as we carry our signs with us, it's okay. So we can still add 9 to get x by itself. Remember, if we do it to one side, we have to do it to the other side to maintain balance, okay? 55 plus 9 is 64. That's my solution I found. X is equal to 64. So we're going to verify that by plugging it in. 55 equals, sorry about that, guys. 55 equals 64 minus 9. 64 minus 9 is 55, okay? So 55 equals 55. And again, that is true, okay? For number 6, I have negative 27 is equal to negative 9x, okay? Negative 27 is equal to negative 9x. Okay, so what we're going to do here is we're going to divide both sides by negative 9 to get x by itself. Okay, negative 27 divided by negative 9 is 3. 3 is equal to x. Let's verify that and plug it in. Negative 27 equals negative 9 times 3. Of course, we know negative 9 times 3 is negative 27, and this is a true solution. Okay, so the name of the game here, guys, is to solve for x, get x by itself and see what it equals, and then we have to verify it to double check and make sure we're correct. If you get a true statement down here in your verification process, you know that what you found was true, and it's a good solution, okay? But if you get an untrue statement down here, that means you're either verifying wrong and not following your order of operations, or your solution's bad, okay? So don't forget the verification process and what we're doing, okay? And that is it for one-step equations.